Welcome to this tutorial slash request for Unreal Engine 4 and Unreal Engine 5, since this will work in both engines. This was actually a request from someone a long time ago, and if you're watching the video, I'm sorry it took so long, but what we're basically going to be doing today is exploring how you can make a side-scrolling game in a 3D world and allow for movement that is not just along one axis but something a little bit more dynamic. So let's jump into it. So here we are inside Unreal Engine 5, and again this tutorial will work for both Unreal Engine 4 and 5. It will just be slightly different in the way that some of the blueprint nodes work, but everything else regarding the classes, the functionality, the math, everything like that will be the same. Also, one difference that there is that currently in Unreal Engine Early Access, since that is the version I'm using right now, there is no side-scroller template as far as I could see. So what we will be doing is we will start off by sort of scrapping how the third-person character template works and make it a sort of 2D character. So you can see that process as well, but if you are in Unreal Engine 4.26 and you have a side-scrolled character, or you're watching this when there's a later Unreal Engine 5 version where the side-scrolling template is available, then that should work just as fine to adapt, and then you can skip the parts where I'm actually remaking this third-person character into the 2D scroller. Anyway, enough babbling. Let's get started with some of the things that we need to do. So the first thing is we have this third-person character here. Let's just make a duplicate out of him so we don't break him, and then we'll call this side-scroller character. So now we have a duplicate here, and then we'll start off with marking the character in the level and right-clicking on him and replacing him with the side-scroller character. So when we start playing now here, actually this apparently has a player start as well, so we'll click on this character and we'll find possess, and we will just say that player 0 is supposed to possess this pawn, which means that if we now play we get this character, and it works exactly like a third-person character normally does. So things to start off with. The first thing that we want to do is we want to find our camera boom, because it's at 300, which is 3 meters of length. We want to go something like 500 or 700 or something further, so we just get a little bit further from the character. So you see we have some space, because we're going to want some space to see that it actually, the functionality that we're creating is going to work. Now that we've done that, what we need to do is actually, let's go create the actual pathing. So the whole backbone of this is to have a spline work as your pathing in your level. So with a spline, if you're not aware, it's a system to draw a path of lines, so you can actually traverse or use that in some way in the engine. And we're going to be using that path to actually work as our walkable path for the character. So it's very simple. We're just going to make a blueprint class and make it of type actor, and we'll call it BP underscore path, just to keep it simple in naming convention ways. And the only thing we need to add here is actually a component of type spline. You want the spline, not the spline mesh. And we'll call the spline path. And that's basically it, done. And to demonstrate how this works now, if we drag out this blueprint into the world, drag it up a little bit, what you'll see is it starts off with 2 points. You have a point over here and you have a point over here, and that's the basis for the spline. Now if I were to rotate this a little bit, because I want to have it actually moving in sideways, because I'm gonna make the character side scroller, right? And then I can click on one of these. Actually, I can't click on the first one and have that one duplicate. I can only duplicate from the first one out. So holding down Alt and then dragging, you can get new spline points generated. So we can do something like this, for example. So this is the point that we're trying to make. We want this character to be able to run along the spline like this, for example. And then we can make it something like it turns over here as well. So that's what we are going to be doing. We're going to make this character follow the spline path that you create like this. So you can make a level where you make a 3D level. You create a spline where the character is allowed to walk, and he will just keep walking along those splines, and you can have it a little bit more dynamic than just having a one axis. So let's start working on our side-scrolling character. The first thing that we need to do on this character is we're gonna be having input only to the right and to the left. And because of that, we can remove our input forward and backward completely. So we'll just jank that out like so. Compile and play now, and I can only move left and right, and forward and backward doesn't do anything anymore. Next part is this character uses the camera to decide which direction to walk for its right vector and stuff like that. So we can cut all of this out as well, because we're not actually interested in that. We're going to be creating something different for that. So this is the first part, to have this just available as our input. Now what we want to do, we want to be able to communicate with our spline. So to do that, for this example, we're going to get the begin play event. So at the start, when this character is created, he's going to try and get the spline. So we want to get an actor by class. And this system that we're going to be doing today will only be having one of these splines available, but you could theoretically have multiples of them and then get all of them and keep track of them, but then the logic for how you're going to move is going to be a little bit more complicated, but that's completely up to you if you want to expand that. But we want to get our BP path here as our actor, and then we want to promote this to a variable so we have it available later on, because we don't want to keep getting this character whenever we want to communicate with it. So we're going to be calling this our spline path. Actually, spline path ref, as in reference. Like so. Now, what we're going to be doing is we're going to get our spline path reference, and from that we're going to get our path, and you'll see it down here. So this means that we have now reached into this object and we have gotten its spline component. So the very first thing that we want to do is we want to find a tangent closest to world location. And the world location that we want to get is ourselves, so actor location. Now you also want to change the coordinate space here to world, and let me just take a pause here now and explain what this actually means. So what we're saying is we want our character's location here, we want to find the point that's closest to this actor and find its tangent for that. So that tangent you can see like this. If you click on any of the points, you will get these. It's actually most clear over here if we take it in a bend. You'll see that there's a line drawn just touching the point of the curve here. Now, this is the definition of a tangent. And the tangent shows you sort of a direction or an angle that is perpendicular to a specific point on the spline. And this is what we're out to get. And the reason for that is we want to find what is our current direction, basically. And once we have our current direction here, we want to normalize this. And the reason for that is, if we go back into our example here again, depending on how far apart these spline points are, the tangents will have different lengths. So if I click on this one, for example, you'll see it has a pretty short tangent, and if I click over here, its tangent is all the way over here, it's much larger. So the reason we're normalizing is because we want this to be a direction, but we want it to be in the scales of 0 to 1, so we can actually work with it with multiplications. and this immediately becomes important now, because now we want to multiply this. And in Unreal Engine 4 now, if you were to do this, you would be able to have a multiply against float, but in Unreal Engine 5 apparently they have changed this, so it's only a multiply. So if we want this to be a float now in Unreal Engine 5, we have to right click on the other node and say convert pin to float. And then we want to promote that variable. We're going to call this variable scan distance. That didn't work at all. Let's try that again. Scan distance. Now the point of this variable is that, first of all, let's set this to a default value of 250 or something like that. If we go back to our map, this means that if we were over here, what we're doing is we're getting the tangent, which is this, we're normalizing it to be a direction of 0 to 1 in the 3 different axes, and then we're saying multiply it by 250, meaning follow the tangent 2.5 meters forward. So if we were to be here, it would go 2.5 meters out in this direction. Now this might not make a whole lot of sense right now, but keep with me here. It'll be more comprehensive momentarily, hopefully. So the next step that we want to do is actually that we want to multiply this value that we have out here now with our value of our axis. So let's do another multiplication and convert to float. And let's do something like this. We'll do a reroute node, and we'll be cleaning this up a little bit later. So if you have OCD about it, don't worry, we will fix it later. So we're just pulling in the axis value here. And the reason for that is we want to find a tangent based on our movement. So when we're playing on a keyboard, we're going to have a value of either +1 for moving right and a -1 for moving left. And then anything in between that, if you would have a joystick which has the ability to like go on a gradient, so like 0.2 or 0.7, depending on how much you actually are holding down the joystick. So we want this to affect our distance as well. So if you're holding down a little bit less, it's going to be scanning shorter. If you're having full speed, it's going to be scanning further ahead. And once we have that, we have a direction. Now we want to actually make use of that direction by finding a different point here. We want to find from this, we want to find a location closest to a world location. And we'll change that to world as well. So if we go back here, basically this means if you were here, we're gonna scan 2.5 meters. It's gonna check which point of the spline is the closest from this point, and it will go and say that this is the point that is the closest. And that means that this is the direction we actually want to start moving towards. So doing this will only work. Let's move this up actually so it doesn't get in the way, and then we'll make a reroute node a little bit. Actually cleaning up a little bit earlier than I had expected, but yeah, I might also have OCD. That's just a direction. We want to find the actual location where this is, and to do that we need to add, by vector math logic, that means we need to add our current location. So that means our actor location over here. So now we have calculated the actual space in the world where this is, and we send that into this node over here, and it will give us the actual spline point where that is the closest spline point for that particular location. Now we want to normalize this again. And the reason we do that is we now have a location where we want to move towards, but we need to have a normalized vector because the direction here is a normalized vector, the one that decides which way we're actually going. So that's why we're normalizing that. And this will be the result that we actually put into the world direction. Now I want to add something here. I want to make a draw debug sphere, and this is to be able to convey to you more clearly what is actually going on. So we're going to make the color something red so we can see it clearly. We're going to make the duration 0.1 since we will be doing this all the time. It doesn't need to last very long. We want to put the thickness to something like 10 so it's clear. We can put the radius to something like 30 or something. Now to demonstrate where we are currently, let's just go in here and press play. So if I were to actually, we're missing something. Input axis right, target right. We don't actually draw where we are debugging. So we want to know, what we want to draw here is the location that we calculated, and we want the location before we actually normalize it. So we want to see this is where we expect the character to be moving towards. So now you see that we're drawing these spheres. Actually, let's make them a little bit smaller. That's a little bit big. How about 20 maybe? Okay, that didn't help a lot. Anyway, so that's up to you if you want to change that. But basically now if I start moving right, you'll see that it'll draw some spheres to the right, and yeah, it'll move a little bit funky. It won't follow the spline at all. And this is all fine for now. It's just showing off that the debugging is working, and this is what we're trying to accomplish. We need to do a few more adjustments here before this will work out. So among the things we want to do, we actually, hold on, this doesn't look right. Yeah, what we're after here. Okay, let's explain a little bit what's going on here. Let's move these so they're not as chaotic, maybe something like that. What's going on here is actually wrong. This currently here is a location. It is not actually a direction, because we need to get just like how we add our own position here to get a direction from a vector, we need to remove our location from here to find out what the direction actually is from here. So let's see, this should be the get actor location, yes. So like so. And this is the value that we should be normalizing, and this is the value that we should be no, it shouldn't be. It should be this value, I think. Let me think a moment. Yeah, I think that makes sense. We want to draw the debug sphere where we have calculated that we're supposed to be moving, and then we want to use the directionality when it's normalized to actually move in that direction that we're after. Let's try this. It should actually move a lot better now. So now you'll see it follows the spline sort of, but we do have some errors here. It's now I'm pressing left, it's going right. I'm pressing right, it's going left. And the reason because this is, if we go back to our character again, we have a input value here which we're using to multiply here, and that's all good and fine for the scan distance, but the world direction is also something that we calculate based on this. So since this value can go between -1 and 1, that means we can end up with a direction that cancels out our math direction. So what we want to have here is actually just a value between 0 and 1. So we want to have an ABS, an absolute, to make sure that it's only a positive value. That way we will always have a scale value that says movement in a positive direction, but the actual direction is calculated by the rest of the logic that we have made here. I hope that makes sense. So if I press right now, I move right. If I press left, I move left, and then it follows the spline. Now I want to make something clear here, and I think the best way to do that is possibly actually by dragging this text here. So let's see if we can drag this text so I can place it under the spline. sort of. And let's see if we can move the splines a little bit so I can demonstrate something here. Maybe something like that. Then we'll take the text again, we'll turn it. This is just so we have a visual indicator of where we are supposed to be running, so you can see how well or how bad this works. So you can see that the character is running on the text, and it seems to be sort of okay. The text here was placed a little bit poorly, it's a little bit to the right of it, but that's fine. So now we actually technically have our movement that we're able to. So you see it stopped over here at the end of the spline, so I can't move further to the left. So the spline actually dictates now where we are able to move. And that's fine for as long as we're running around like this, but in most games like this you want to be able to actually jump as well. And look what happens when we do that. We completely break off the spline, and even though we can make our way back by running again, it doesn't look good, and it's not good if the player is able to actually jump away from the spline in case you have something like an abyss or something like that and the player can fall off. So what this has to do with is a couple of things related to the character movement. If we go to the jumping falling part here, you can see that we have something called air control. It is a value between 0 for zero control and 1 for full control. This is the first thing we need to change. We change the air control to 1. This will allow the character to be more maneuverable when it's jumping around in the air. But you can still see that it sort of leaps out of the spline a little bit. And that is also because there are different parameters in the character movement that is working against us here. So we have something called falling lateral friction, and actually you could also up the friction for the walking, because the character sort of slides a tiny bit with 8 in friction, so if you increase this it will be even more rigid to the spline, but it works fine with 8 for my tests. But we need to fix this for the character when it jumps. So if we set this to something like 500, something large like that, and start playing, you'll see that it will no longer be going outside the lines of the spline, and we can actually show this by having a really sharp turn also as well. So if we add the spline point over here, if I can press it, something like so, that's a pretty sharp turn. Let's try and jump just before reaching that turn and see what happens. So you see, it turns around. So yeah, that basically is all you need to get this to work. Now let's improve upon this a little bit. Let's have the jumping speed be something like 1200. What this means is that we can jump much higher. Whoa, okay, that was a little bit high. Anyway, it will be fine for our demonstration purposes. Because what we want to do now is we want to... Most of these games are platforming games, so you want to have a platform, right? So let's put a platform somewhere. So we drag this over here, we'll rotate it a little bit, something like that, and we can scale it a little bit, then put it up. So something that allows us to actually run under it, yet we can still jump up and be on top of it. And you see it will still run around here. Now what you might notice is that it's actually running a little bit slower. And this has to do with the fact that it's finding its point below. You can see the red spheres. And it's actually calculating that its direction to run should be pointing downward as well, because the point is actually downwards. So if that's something you want, then that's fine, I guess. But if you didn't want that, then you could actually normalize that out by removing the Z component. Now, this video is starting to be pretty long already, so I won't be showing that quite here, but it needs to be taken out of the calculation that the set point is a factor for it to determine where, or the world direction to run towards. You only want the X and the Y, because you can see here X and Y is the dimensions of where you want to have the character moving, and the Z is just for the jumping, so you don't want that to affect it. It would also show up if you were to put something like, if you were to take this spline up here and take it something like that. It might not be noticeable, but you can see that it debugs up there, and it's actually moving slower while it has that debug sphere up there, because it wants to go upwards, but it can't go upwards. So if you were having a slope here, a natural formation of the land that was going up, and that's why this spline was going up like that, then that would be fine. You could still eliminate the Z and just have the X and Y, and it would move fine along the axis, and then the ground would keep him up and down depending on where the character is. Yeah, I think that works well for this request. I hope it is useful for you, and that you found this something that you can put in your toolbox to possibly use in the future. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any suggestions or comments you might have down below. Subscribe and share this video if you want to see more like it in the future. That is all for now. Keep on learning. Take care.